Hello and welcome to the Shine Sleep channel. I'm so happy you're here. Maybe you've had a long day. Maybe you still carry the fatigue of that day on your shoulders. Maybe your mind is constantly trying to figure things out, find answers, remember things. All of this is normal. All of this passes. Now all you need to do is relax. Tonight I'm going to tell you a story. A very old story. The oldest story that ever existed. The story of time and space itself. The story of the moment light first set out on its journey. The story of how atoms, stars, galaxies, and finally those tiny particles that make you up, came together. We won't rush to tell this story. We'll go slowly. Very slowly. We'll breathe between sentences. We'll leave silence between concepts. And if at some point your eyes close, that's exactly what should happen. If you're ready, we'll begin. But first, for a moment, just for a moment, pay attention to how your body feels. Is your back touching the bed or couch? Are your legs stretched out? Do you notice how your chest quickens and slows as you breathe? Good. Settle right there now. A very long time ago, so long that even the word long time is insufficient, there was nothing. Hello and welcome to the Shine Sleep channel. I'm so glad you're here. Maybe you had a long day today. Maybe you still carry the fatigue of that day on your shoulders. Maybe your mind is constantly trying to figure things out, find answers to things, remember things. All of this is normal. All of this passes. Now, all you have to do is relax. Tonight, I'm going to tell you a story. A very old story. The oldest story that ever existed. The story of time and space itself. The story of the moment light first set out on its journey. The story of how atoms, stars, galaxies, and finally those tiny particles that make you up, came together. We won't rush to tell this story. We'll go slowly. Very slowly. We'll pause between sentences. We'll leave silence between concepts. And if at any point your eyes closed, that's exactly how it should be. If you're ready, we'll begin. But first, for a moment, just for a moment, pay attention to how your body feels. Is your back touching the bed or the chair? Are your legs extended? Do you notice how your chest quickens and slows as you breathe? Good. Settle right there now. A very long time ago, so long that even the word long time is insufficient, there was nothing. Chapter 5. The prison years of the first LIGHT4. The first 380,000 years after the Big Bang. The universe existed in a way that we would have difficulty imagining today. It was a plasma-free electrons, protons, and photons particles of light fused together. It was so crowded and so heavily packed that no photon could travel in a straight line. They constantly collided, bounced back, and changed direction. Light existed, but it couldn't be seen. The universe was filled with light, but light was imprisoned. This 380,000-year period is known in cosmology as the period of opacity. The period when light lost its freedom, and then the temperature dropped. Slowly, over millions of years, the temperature of the universe fell below a certain threshold. And at that threshold, a miracle happened. Electrons settled around protons. Neutral hydrogen atoms formed. For the first time, this step is called recombination. In cosmology, a somewhat misleading name, because they are actually combining for the first time, not anew. But the name stuck. The moment neutral atoms formed, the barrier to light was removed, and photons that had been locked in a cage for billions of years, began to fly freely for the first time in every direction. At infinite speed, light spread throughout the universe. Traces of that light exist today. The universe has expanded since then. As it expanded, the wavelengths of light lengthened. It ceased to be visible light. It moved towards infrared. Then it entered the microwave region. Today, this light is known as the cosmic microwave background radiation. And there's something very interesting. It's still here. Right now, it surrounds you from all directions. Far below room temperature, just 2.7 degrees above absolute zero, but it's there. A light from the universe's infancy is still floating through space. It's still traveling. In a sense, the sound of the Big Bang still echoes, and you sleep within that sound. Chapter 6. Cosmic Microwave Background and the Universe's Baby Crying, 1965. Two radio engineers in New Jersey faced a strange problem. Arno Penzias and Robert Wilson were working on a highly sensitive radio antenna. But the antenna had a constant, steady noise in every direction. No matter what they did, they couldn't get rid of it. They checked the antenna. Everything was in place. They checked the wires. No problems. And then, they found a pair of pigeons had built a nest inside the antenna. They cleaned it. They chased the pigeons away. Did the noise stop? No. At the same time, a group of physicists at Princeton University was doing a theoretical calculation. If the Big Bang really happened, there should be radiation left behind. This radiation should come from all directions of the universe with equal intensity, and it should be in the microwave region. At the temperature of the universe today, the two groups were working independently. When they combined, the answer was clear. The noise Penzias and Wilson heard was the light of the universe that was 380,000 years old. The cosmic microwave background radiation ceased to be a theoretical prediction. It was real. It was measurable. It was tangible. It had almost been ignored because of a few pigeons. This discovery brought the Big Bang theory to an undisputed position. But there's more. This radiation is almost perfectly the same temperature in every direction. But the word almost is important, because there are differences of 1 in a million. Microscopic fluctuations. Slightly hotter in some regions, slightly colder in others. These differences show that matter wasn't evenly distributed at that time. Some places had a little more matter, some places had a little less, and these little bits grew over time through gravity. Denser regions attracted more matter. As they gathered more matter, they became stronger. And billions of years later, these microscopic fluctuations transformed into giant structures, galaxies, star clusters, planets, and one day, on one of them, life. If those tiny temperature differences hadn't existed, the universe would be a different place today. Smooth and homogeneous, structureless, but they existed, and because of them, we exist. Chapter 7. Cosmic Inflation and Faster Than Light, EXP. Let's pause for a moment and consider. The cosmic microwave background radiation is incredibly Regions at opposite ends of the universe are at almost the same temperature. But these 2 points are so far apart that they couldn't have touched each other even at the speed of light. How can they be so similar if they've never communicated? Cosmologists call this question the horizon problem. And the answer comes from the theory of cosmic inflation. In short, immediately after the Big Bang, the universe expanded at an incredible speed for an extremely short period of time, much faster than the speed of light. But wait. Doesn't Einstein's theory of relativity say that nothing can exceed the speed of light? Yes. But this rule applies to matter and energy. Space itself is not subject to this rule. Space can expand as fast as it wants, and it did. The universe, which was subatomic in size, reached a size far greater than the observable limit of the universe today in a tiny fraction of a second. During this expansion, that initial small region, all in contact, all exchanging heat, expanded to enormous proportions. That's why the far corners of the universe are so similar today. They were all once neighbors. Inflation theory also explains that those tiny quantum fluctuations, the matter-antimatter uncertainties, the energy vibrations transformed into seeds that would grow into massive structures through inflation. So the origin of galaxies is based on quantum uncertainty. The universe took the smallest vibrations and transformed them into structures billions of light years wide. In a very quiet moment, a very noisy future was hidden. Chapter 8. The Dark Ages and Esselian Sciatha universe was now full of matter and energy. The first atoms had formed. Light flowed freely, but there were no stars yet. This period is called the Dark Ages in cosmology, a misleading name, because it was most likely not truly dark. That old light was still drifting through space. But there was no new light. No stars had yet ignited. Space was filled with vast clouds of hydrogen and helium. These clouds slowly rotated, drifting within themselves in a very, very slow choreography. And gravity was at work. Patiently, continuously, tirelessly, denser. Regions pulled in the matter around them. As they were pulled, they became denser. As they became denser, they pulled more strongly. This cycle continued for millions of years, and one day, or rather, at the end of hundreds of millions of years, a gas cloud crossed a threshold. It had compressed enough. The temperature at its center increased, so much that the atomic nuclei drew closer together. And at that proximity, nuclear forces came into play, fusion began. Two hydrogen atoms came together and became helium. This fusion released energy. And that energy was emitted as light. The first star was born. The Dark Ages were over, but that star, this first-generation star, was very different from today's stars. It could be hundreds of times larger than our sun, thousands of times brighter. Its life was short, its death violent. These giants burned briefly, and then they died exploding. But in their deaths, they left behind the most magnificent legacy. The interior of a star is a kind of furnace. At the center, under high pressure and temperature, light atoms fuse together to form a network. Hydrogen turns into helium. Helium turns into carbon. Carbon turns into oxygen. And this chain continues. Oxygen, silicon, sulfur, calcium, iron. When we get to iron, something changes. Iron core fusion no longer gives energy, it consumes energy. The star can no longer produce fuel in its core. It can no longer resist gravity, and it collapses. It collapses very quickly. In a fraction of a second, a star the size of our sun is compressed to the size of a city, and there is a recoil. A spectacular outward explosion. A supernova. In this explosion, a light is emitted that for a moment surpasses the light of the entire galaxy. And with this explosion, all the elements the star produced during its lifetime are hurled into space. Carbon, oxygen, iron, nitrogen, calcium, a cloud of elements scattered hundreds of light years across space. These clouds floated in space for a while. Then they merged with other clouds. They formed small clusters, and those clusters gathered around new stars. Some began to orbit the star. As they orbited, collided, merged, planets formed, and some planets, under certain special conditions, with certain chemical compositions, liquid water, the right temperature, the right molecules, became suitable for life. Now, let me tell you something. The iron in your fingertips was once inside a star. The oxygen that fills your lungs when you breathe was produced a long time ago in a star's fusion furnace. The calcium in your bones was scattered into space by a supernova explosion. You are not stardust. Chapter 10. The formation of galaxies and the cosmic WHE. This universe, where matter is reborn time and again, and new stars are born from the death of old ones, began to form larger structures over time. Stars gathered together under the force of gravity. Galaxies formed, but galaxies are not alone. If you look at a large-scale map of the universe, you see a striking pattern. Galaxies seem to be lined up along giant networks, fibers, knots, gaps. The cosmic web, billions of galaxies, like the Milky Way, are clustered in the fibers of this web. The vast emptiness between them is almost entirely empty. But along these fibers, galaxies follow one another. How did this structure form? Thanks to dark matter. Dark matter, as its name suggests, is invisible. It cannot emit, reflect, or absorb light. But it has weight. And because it has weight, it has gravity. More than 80% of galaxies are held together by the gravitational pull of this invisible matter. Without dark matter, galaxies would disintegrate under the force of their rotation. We can't see it. We can't touch it. We can't measure it. We can only see its effect. In the unexpected speed at which galaxies rotate, in the unexpected mass distribution of galaxy clusters, this mysterious matter makes up about 27% of the universe. And ordinary matter stars, planets, gas clouds, is only 5%. The remaining 68%. Dark energy. But we'll get to that in a moment. Chapter 11. The patient music of GS. Step back at this point and look at the big picture. The universe is 13.8 billion years old. Galaxies formed in the first billion years. The first stars ignited and died. A second generation of stars was born. And this process continued generation after generation. Our Sun formed about 4.6 billion years ago, a relatively young star. Many generations of stars had passed before, and the elements formed by those generations were within the gas cloud from which the Sun was born. As the Sun formed, the surrounding gas and dust also formed a disk, the first state of the solar system. Within this disk, particles collided and merged. Small rocks grew. Large rocks turned into planets. Earth formed in this process. 4.5 billion years ago, initially, it was quite different from today. Volcanic and bare, molten rock, a dense carbon dioxide atmosphere. There was no water, or there was, but, under very different conditions, and then something happened. We still don't know exactly which started first. But at some point, on this bare planet, chemical reactions began to accumulate. Some molecules gained the ability to replicate themselves. Life began, single-celled organisms, over billions of years, slowly changing, multiplying, and then multicellular life. More complex, more adaptable. Seas, land, air, living things adapted to every environment, and millions of years later, a species emerged. With its tiny hands, it could shape stones. It could create meaning with sounds. It could control fire. It created symbols. It made art. It looked into other people's eyes and tried to understand what they were feeling. And one night, it looked up at the sky and wondered, what is all this? Chapter 12. Dark Energy and the Accelerating Expansion. In the late 1990s, a surprising discovery was made in the world of cosmology. Scientists were trying to measure the rate at which the universe was expanding by studying distant supernova explosions. Supernova are used as standard candles. You can calculate how far away they are by looking at how bright they appear. The expectation was, the universe is expanding, but it should be slowing down due to gravity. Maybe one day it will stop. Maybe it will be collapsing back down, but the data showed the opposite. The universe is not slowing down, it is accelerating. Distant galaxies are receding faster than gravity allows. This discovery was so astonishing that most scientists refused to believe it. The data was checked repeatedly. Different teams studied different supernova. The result remained the same. The universe is expanding at an accelerating rate, and something is doing it. A force or a property. It's called dark energy. What is dark energy? It's unknown. It's truly unknown. It can't be measured by any detector. It can't be precisely defined by any formula. Only its effect is known, an energy that exists at every point in space, driving the universe to expand. In Einstein's equations of general relativity, it was possible to include such a term. Einstein once added such a term as the cosmological constant because he wanted a static universe, then removed it. Perhaps he wasn't wrong. Perhaps that term really exists. Today, 68% of the universe is dark energy. This means we don't know what the majority of the universe is. A strange feeling, but it's also a wonderful feeling, because it means there's still so much to learn. It means the universe is constantly full of mysteries, and mystery is the habitat of curiosity. You are a star. Chapter 10. The formation of galaxies and the cosmic web. This universe, where matter is reborn time and again, and new stars are born from the death of old ones, began to form larger structures over time. Stars gathered together under the force of gravity. Galaxies formed, but galaxies are not alone. If you look at a large-scale map of the universe, you see a striking pattern. Galaxies seem to be lined up along giant networks, fibers, knots, gaps. The cosmic web, billions of galaxies, like the Milky Way, are clustered in the fibers of this web. The vast emptiness between them is almost entirely empty. But along these fibers, galaxies follow one another. How did this structure form? Thanks to dark matter. Dark matter, as its name suggests, is invisible. It cannot emit, reflect, or absorb light. But it has weight. And because it has weight, it has gravity. More than 80% of galaxies are held together by the gravitational pull of this invisible matter. Without dark matter, galaxies would disintegrate under the force of their rotation. We can't see it. We can't touch it. We can't measure it. We can only see its effect. In the unexpected speed at which galaxies rotate, in the unexpected mass distribution of galaxy clusters, this mysterious matter makes up about 27% of the universe, and ordinary matter stars, planets, gas clouds, is only 5%. The remaining 68%. Dark energy, but we'll get to that in a moment. Chapter 11. The Patient Music of G.S. Step back at this point and look at the big picture. The universe is 13.8 billion years old. Galaxies formed in the first billion years. The first stars ignited and died. A second generation of stars was born, and this process continued generation after generation. Our Sun formed about 4.6 billion years ago, a relatively young star. Many generations of stars had passed before, and the elements formed by those generations were within the gas cloud from which the Sun was born. As the Sun formed, the surrounding gas and dust also formed a disk, the first state of the solar system. Within this disk, particles collided and merged. Small rocks grew. Large rocks turned into planets. Earth formed in this process. 4.5 billion years ago, initially, it was quite different from today. Volcanic and bare, molten rock, a dense carbon dioxide atmosphere. There was no water, or there was, but, under very different conditions, and then something happened. We still don't know exactly which started first. But at some point, on this bare planet, chemical reactions began to accumulate. Some molecules gained the ability to replicate themselves. Life began, single-celled organisms, over billions of years, slowly changing, multiplying, and then multicellular life. More complex, more adaptable, seas, land, air, living things adapted to every environment, and millions of years later, a species emerged. With its tiny hands, it could shape stones. It could create meaning with sounds. It could control fire. It created symbols. It made art. It looked into other people's eyes and tried to understand what they were feeling. And one night, it looked up at the sky and wondered, what is all this? Chapter 12. Dark Energy and the Accelerating Exponential in the late 1990s. A surprising discovery was made in the world of cosmology. Scientists were trying to measure the expansion rate of the universe by studying distant supernova explosions. Supernovae are used as standard candles. You can calculate how far away they are by looking at how bright they appear. The expectation was, the universe is expanding, but it should be slowing down due to gravity. Maybe one day it will stop. Maybe it will be collapsing back, down. But the data showed the opposite. The universe is not slowing down, it is accelerating. Distant galaxies are moving away faster than gravity allows. This discovery was so astonishing that most scientists didn't want to believe it. The data was checked repeatedly. Different teams studied different supernovae. The result remained the same. The universe is expanding at an accelerating rate, and something is doing it. A force or a property. It's called dark energy. What is dark energy? It's unknown. It's truly unknown. It can't be measured by any detector. It can't be precisely defined by any formula. Only its effect is known, an energy that exists at every point in space. Driving the universe to expand in Einstein's equations of general relativity, it was possible to include such a term. Einstein once included such a term, cosmological constant, because he wanted a static universe, then removed it. Perhaps he wasn't wrong. Perhaps that term really exists. Today, 68% of the universe is dark energy. This means we don't know what the majority of the universe is, a strange feeling, but also a wonderful feeling, because it means there is still so much to learn. It means the universe is constantly full of mysteries, and mystery is the habitat of curiosity. Chapter 13. The future of the universe and the distant SEO. Dark energy remains constant, and it seems to have so far. The universe will continue to expand, forever, billions of years from now. All galaxies except the closest galaxy clusters will have moved beyond our field of vision. Not only will they be moving away, but space will expand so rapidly that light from it will never reach us. The universe will technically exist, but it will become invisible. Then stars will age and die. White dwarfs, neutron stars, black holes. New star formation will slow down. Gas will run out. Galaxies will darken. Trillions of years later, the last stars will also fade. Only black holes will remain, and they, too, as Stephen Hawking predicted, will evaporate in a very, very slow process, emitting tiny particles. Hawking radiation, an evaporation that takes trillions and trillions of years, and in the end. Particles, space. Silence. This is the big freeze scenario. Another possibility, if dark energy strengthens over time. The expansion will accelerate so much that galaxies, stars, planets, molecules, and eventually, even atoms will be torn apart. The Big Rip, or another possibility, dark energy weakens and reverses. The universe slows down, stops, begins to collapse back. Everything comes together again. The Big Crunch. And perhaps a new universe is born from that point. A cyclical cosmos, we don't know. But this uncertainty is an invitation to wonder for humanity. Chapter 14. The James Webb Space Telescope, and the first glance at the light in 2022. The first images from the James Webb Space Telescope were released on, and the world held its breath. This telescope is sensitive to infrared light. This allows it to see the redshifted light created by the expanding universe. That means it can see the light from very distant galaxies, which means the light from very old galaxies. In the first images, thousands of galaxies appeared in a small area of dark sky. Galaxies, each containing hundreds of billions of stars, all there, in a tiny patch of sky the size of a fingernail. And some of these galaxies are over 13 billion years old. Galaxies that formed just a few 100 million years after the Big Bang. Some appear far larger and more mature than expected for such an early period. This suggests that our theories may need updating. The universe still amazes us. Every new telescope, every new discovery tells us, we are not finished yet. We are still learning. And as we learn, the universe appears even deeper and more beautiful. Chapter 15. You and the meaning of the universe. At the end of this long journey, I want to return to you for a moment. You are here now. Hearing this sound, or reading these words, perhaps your eyes are half closed. Perhaps your breathing has slowed down a little. Perhaps your thoughts have begun to slowly drift apart. You are the final link in this universe's 13.8 billion year journey. In the beginning, there were particles, then atoms, then stars, then planets, then seas, then the first cells, then trilobites, dinosaurs, mammals, then humanity, and then you. Each link in this chain rested upon the one before it. Without carbon from supernova explosions, there would be no organic chemistry. Without organic chemistry, there would be no life. But I also want to say this. From the unconscious matter of the universe, a conscious being arose, and that conscious being is wondering about its own origins. The universe has begun to think about itself, through you. This is no small thing, in the 13.8 billion year history of the universe. As far as we know, only on Earth, as far as we know, only in the human mind, is the universe able to question its own existence. A collection of atoms asking, why do I exist? Stardust, wondering, what was the beginning? A supernova remnant, thinking, what was before the darkness? You. Chapter 16. Lights of the Night and Distant Galaxies. You looked at the night sky today, on a dark night, in the open air. Without city lights, you would see thousands of stars. Some of the brightest are actually galaxies. The Andromeda Galaxy is visible to the naked eye, like a faint smudge, 2.5 million light-years away. So the light you see right now set off from there, 2.5 million years ago. Homo sapiens didn't exist then. Our ancestors were making stone tools. That light traveled all that time, and now it has reached your eyes. And the light from even more distant stars set off millions, billions of years ago. The sky is actually a time machine. Depending on your perspective, you're looking into the past. Now, take this idea with you as you begin to sleep. Each of those distant lights is a message from its own time. A light form of a star saying, I was here to end these messages. Having traveled billions of years, have arrived at this very moment as your eyes close to sleep. It's not a coincidence, it's just time. Chapter 17. Sleep and the EON-IVRA/sleep is a strange thing. Consciousness disappears. Time skips. Thoughts scatter, but the body continues. The heart beats. The lungs expand. Nerve cells fire. What was learned during the day is embedded in synapse connections, and during REM sleep, the brain is sometimes so active that it doesn't even notice the daytime. We dream. Dreams can be strange, incoherent, illogical, but sometimes they are surprisingly real, surprisingly profound. And sometimes, in that depth, we seem to understand something. A connection, a solution, a feeling. Perhaps sleep is when the brain explores its own universe. Just as scientists explore the external universe, the mind explores, rearranges, and constructs meaning within itself during sleep. Tonight, take the billions of years of the universe's history with you. If you fall asleep, that history will go with you. Particles and light, stars and galaxies, time and space, and in the midst of them, on a planet, in a bed, or on a couch, you, having listened to this journey. End. The ongoing SONGtha sound of the Big Bang reverberates throughout the universe. The cosmic microwave background radiation, a remnant of that first moment billions of years ago, still drifts through space. Every second, everywhere. Stars are shining right now. Some are born, some die. Somewhere in space, a supernova explodes, scattering new elements into the universe. Somewhere, a gas cloud collapses, and a new star ignites. Galaxies rotate. Dark energy drives expansion. Dark matter holds structures together, and on this planet, in this room, you breathe. A consciousness within the universe, contemplating the universe. It's something so subtle, so rare, so precious. Tonight, as you sleep, carry that magnitude with you for a moment. Then let it go. Because magnitude cannot be carried, it can only be felt. And now, the time for feeling is over. Chapter 18. Inside the Milky Way. Now consider your exact location in the universe. You are on a planet. This planet orbits a star. That star floats inside a massive galaxy. And that galaxy is just a tiny point in one of billions of galaxies. The Milky Way galaxy. Somewhere between 100 billion and 400 billion stars. We don't know the exact number, because we are inside it. It's hard to count from the inside. You can't see exactly how many buildings there are in a city while driving on a flat road, but if you looked from above, everything would be clear. We can't look at the Milky Way from the outside, but by studying other spiral galaxies, we understand what our own galaxy looks like. A large, flat, rotating disk, a dense center in the middle, and in that center, most likely, a giant black hole. This black hole, which we call Sagittarius A, is 4,000,000 times the mass of our Sun, and our Sun is far from this center, in a relatively calm region. In an arm of the galaxy, perhaps this calmness is important, because the regions near the center of the galaxy are quite chaotic. Intense radiation, frequent supernova explosions, gravitational shocks, quite a harsh environment for life, but here we are, on the edges of the galaxy, in a calm arm. On a planet with liquid water orbiting a middle-aged stable star. Is this location a coincidence? Maybe, maybe not. But all these conditions had to come together, and they did. I want to do a scale storm exercise for you. Let's compress the 13.8 billion-year history of the universe into a calendar year. The Big Bang on January 1st. Today is midnight on December 3, one Saint dot in this calendar. The first stars formed at the end of January. The Milky Way galaxy began to take shape in February. Our sun rose at the beginning of September. The Earth formed in mid-September. The first signs of life began at the beginning of October. Life arrived in mid-November. Dinosaurs appeared on December 26th and became extinct on December 30th. Homo sapiens, all of human history, appeared at 11:59 p.m. On December 31st, written history, the pyramids, ancient Greece, Rome, the Middle Ages, the Renaissance, the Industrial Revolution, to world wars, the space race, and today, all in the last 10 seconds. When you feel this scale, it becomes clear how new and rare human existence is. But consider this: in these 10 seconds, humanity learned to control fire, to write music, to try to understand other people, to look at the sky and ask questions. So much was learned in 10 seconds. And in these 10 seconds, you exist. Now, I want to talk to you about something very small, an atom. It has a nucleus, protons and neutrons. Around it are electrons, in clouds of possibilities. It's so small that there are more atoms in a glass of water than in all the water droplets on Earth. And we are made of these atoms. Each one has a history. Every proton, every neutron, has existed since the Big Bang, in different forms, in different places, in different structures, but always there. An oxygen atom that enters your lungs when you breathe. Today may have once been in a drop of ocean. Perhaps it was in the leaf of a forest tree. Perhaps a dinosaur breathed it. And before that, long before that, it was inside a star. You are inside a star. Or, rather, the things that were inside a star are now forming you. And when these atoms came together, a miracle occurred. Consciousness, awareness, a being that can say, I exist. Physics teaches us about atoms. Chemistry teaches us about molecules. Biology teaches us about cells. Neuroscience teaches us about neurons. But none of them can explain why, when these atoms come together, something is felt. Why does pain hurt? Why does beauty seem beautiful? Why does a piece of music tighten your chest? Consciousness is science's greatest unanswered question, and you are the living example of that question. Millions of light years away. Almost complete emptiness. But the word almost matters, because there are particles there too. Rarely, maybe 1 proton per square meter. But it's still there. Even nothingness isn't truly empty. Quantum mechanics tells us that complete emptiness is impossible. Even in the deepest vacuum, virtual particles are constantly forming and disappearing. Energy fluctuates. Space vibrates. Even in its quietest state, nothingness is not silence. That's a different and wonderful idea. Even in the most desolate corners of the universe, something is happening, and billions of light years away from those most desolate corners, on this planet, in this room, your heart is beating. The most complex, most unique form of the universe's vibration. Every star dies one day. Our sun, in about 5 billion years, when it runs out of fuel, will first swell it, will become a red giant. It will swallow Mercury and Venus, maybe Earth, too. But then it will slowly shrink. It will become a white dwarf. It no longer burns fuel, it just cools down, a slowly dying ember over billions of years. This might seem like a bad ending, but consider this. The elements currently undergoing fusion reactions within our sun will eventually scatter into space, and those elements, perhaps billions of years from now, when they gather around a new star, may form a new planet. Perhaps the conditions on that planet will also be suitable. Perhaps something will happen there too. Perhaps someone there will look up at the sky and ask, stars don't die. They transform. Matter doesn't disappear, it changes form. And this great cycle, birth, life, death, rebirth, is true not only for humans, but also for stars, galaxies, and perhaps the universe itself. Every ending carries the seed of the next beginning. Sunlight appears as a white color, but if you pass it through a prism, it turns into a hue: red, orange, yellow, green, blue, purple. All the colors are hidden there, intertwined. Light is normally a wave, and different colors mean different wavelengths. Red is a longer wavelength, purple is shorter. But these colors that our eyes can see aren't all the light. Beyond red is infrared. You can't feel it, but you do feel it as heat. The warmth from the sun comes largely from infrared radiation. Further on, there are microwaves. There are radio waves. Beyond blue is ultraviolet. That imaginary ray that sunscreen tries to block, that burns our skin. Further on are the waves we use in X-ray machines that make bones visible, and at the very end are gamma rays, the most active, most powerful radiation in the universe. All of this is the same thing, the electromagnetic spectrum, just the same type of wave, vibrating at different frequencies. Our eyes are sensitive to only a tiny fraction of this amazing spectrum. The vast majority of the universe is invisible, but it exists. Now, in this room, X-rays are passing through. Radio waves are passing through. Cosmic background microwave radiation is passing through. Infrared from the sun is passing through. All of it is filtering through you. Around you, off the walls of the room, and you don't feel any of it. The universe is far more crowded than you see. Right now, every second, trillions of neutrinos are passing through your body. Stop. Read that again. Every second, trillions. Through your body, neutrinos are particles created in fusion reactions in the sun's core. They are almost weightless. They have no charge. They interact with other particles almost never. That's why they pass through everything. They pass through the earth. As if it weren't there, they pass through you. As if you weren't there. To stop a neutrino, you'd need a mass of matter denser than lead. So massive, light years thick, and yet, some of them interact so infrequently that they can be occasionally captured by giant detectors. Buried underground. In the ice cube experiment, thousands of sensors are buried kilometers beneath the ice of the South Pole. And every now and then, a neutrino collides with a particle there, releasing a small burst of light. Neutrinos from the farthest reaches of the universe travel hundreds of millions of light years to manifest themselves in the ice of the South Pole. And you, carrying that ghost, spend this night with it. Trillions of neutrinos passed through you as you listened to this story. You felt none of them. Two black holes merged, swirling around each other, billions of light years away. It was such a violent event that it created waves in the fabric of space. Gravitational waves. Einstein calculated a century ago that these things must exist, but the technology of the time couldn't measure them, because as gravitational waves pass, space stretches and compresses slightly. How much? It's necessary to measure a shift equivalent to 1/1000th of a proton's diameter in a tube, several kilometers long. That's incredible precision. The LIGO detector achieved this, and in 2015, it detected the vibration from the merger of two black holes. The wave traveled through space for billions of years. It filtered through stars. It crossed galaxies. And finally, it reached a detector built by humans on a small planet. And there, in that subtle vibration, we heard the death dance of black holes. We think space makes no sound. But gravitational waves are, in a sense, the sound of space. And now we can hear that sound. But it was all real. Every morning when the sun rises, when the earth actually rotates, our faces are turned towards the sun again. This cycle has been going on for 4.5 billion years. Days come and go. Seasons change. Years accumulate. And within this accumulation, people are born, grow, live, and die. But the cycle continues. Dawn isn't the same every morning. A different angle of light. Different clouds. Different humidity. No sunrise is exactly the same as the previous one. But we call it morning again. Habit erases repetition. Yet every morning, the light from the sun is new. Those photons are different from those of yesterday morning. Photons that left the sun's surface 8 minutes ago. Photons that didn't exist until that moment. Every morning is the first morning, and every night, like tonight, is time to rest. The cycle progresses like this. Energy comes, is spent, rests, is renewed. You are also a part of this. Cycle. Sleep is a small form of rebirth. The boundary of the observable universe is approximately 46 billion light-years away. Light travels that far. But because the universe is expanding, that distance is now much greater. What lies beyond that boundary? We don't know. Perhaps there are more universes, filled with similar galaxies, similar stars. Perhaps the universe is truly boundless, and everywhere there are places like us that don't fit within those boundaries. Some theories even suggest that if the universe is truly infinite, then every possible combination must have occurred somewhere. Someone, just like you, experiencing this very moment, with your exact memories, probably exists somewhere in the universe. Is this idea disturbing or beautiful? Perhaps both. Not all the noise of the universe reaches you. Only what needs to reach you does. The warmth of the sun, the gravity of the moon, the oxygen in the air, and tonight, the words of this narrative, they are all there. They will be there while you sleep. When you wake up in the morning, the sun will have risen again. The planets will still be spinning. The universe will still be expanding, and you, with a consciousness belonging to a new day, will be here again. Good night. Sweet dreams.